is Intro to Data Science. We're going to kind of just go over an introduction to what it is, what the typical process looks like, and then cover some of the first steps, which is like data wrangling and data visualization. And then the second part of this course is going to be right after. So you are more than welcome to stay, and in that it's going to be an intro to machine learning. So we'll go over kind of that next step of the data science pipeline. Yeah, George, are you ready to like?
Yeah, you can start.
Officially get going?
Yeah.
Okay, cool. So I think on the Datathon website, there should be a link. If you go to the events page on TAMU Datathons, TAMUDatathon.events or /events, and then if you click on this course, there should be a Google Colab link there that'll take you to this exact page that I'm on. And if it, you might need to like make a copy so that it's not mine. I don't want y'all like editing exactly what I'm doing right now. You can kind of follow along. You can run the code as we go through it, see what it looks like, and then also take it with you as you're doing some of your other projects. So this will be like a really good reference for you guys as you're on. All right, so let me know if y'all, like throughout the course, if y'all have any questions, like feel free. I want this to be interactive, so just kind of stop me at any time and ask questions, and I'll do my best to answer them for you guys. So we're going to start with just a quick background just to get y'all familiar with what it looks like to be in this kind of environment. So a Jupyter Notebook, which is what this website right here is based off of, it's just an open source web app. It allows you to create shared documents that contain live code, versions, visualizations, etc. So it's something that is used commonly, and Google Colab is just the Google version of that. It has some really nice features. I do all of my data science projects pretty much in Colab. Because just like all the other Google products, it's really shareable, which is nice. It like automatically saves. It runs on Google Cloud, so it's just like a really good platform to do some data science on. So that's what we're working on. That's what this notebook is in. And then some other features. So Markdown. If you look through a notebook like this, I don't know if this may be some of y'all's first time working in a notebook environment, but it's really neat because you can add code and text blocks. So code is just where you run your normal Python code. You can also do Markdown in here too, which is how it looks all fancy and nice. So in an environment like this, you would have your text sections and your code sections and then the output. So that's kind of what you'll see as we go through this. All right, and then as far as what this course is in, it's in Python. That's what I'm showing y'all today. And data science can be done in a lot of different languages. That's just the one that I have used the most, and so that's what I am choosing to show you guys today. And there are some good reasons for that too. Python is really, really popular right now for data science. There are a lot of great packages that you can just use kind of right out of the box. It's really taken the lead in terms of what people are using right now. And there's some other things that you can do too, like I mentioned. So like Excel, you can do some data science in Excel, but it just isn't really scalable, and same as some of the no-code platforms too. All right, so that's the background, and now we will start talking about data science. So I love this definition right here of data science, and just to give credit where credit is due, a lot of this notebook is taken from my friend Josiah, who made it a couple years ago. So there's some tweaks, but just wanted to give him credit for that. So data science is, at its core, about asking meaningful questions, navigating the path to a data-driven answer to those questions, and then providing meaning to that result. Data science is inherently one of the most human things we can do, to provide meaning to the information around us. The skill to be a data scientist lies primarily in the ability to be analytical and purpose-driven, and that's why many are able to be a data scientist, and nearly all fields need data scientists. So I love that definition. I think it's so cool. That's why I was really drawn to data science, is because I wanted to go out and solve problems. And I also love like how it touches so many different fields. You could be a data scientist in literally any field, which is really cool. And I think that keeps your job super exciting to know that these skills that you're doing right now, you could go transfer and apply to just about anything you're interested in. And so this little graph shows like the intersection of how you can need like CS, stats, and then business knowledge, and kind of like at what points in the process that's needed. But just the takeaway there is that it's just really a multifaceted field, right? With just an intersection of a lot of different things. And then also I put this graph in here. I'm not really going to go over it, but this, when you start applying for jobs, you realize very quickly that they use the term data scientist differently across companies. And so you never really quite know what they're talking about. So these are some other terms that you may see when you're applying for jobs, and just kind of what the differences in those roles would actually be. All right. So the data science process, this whole first section that's in red is what we're going to try to go over in this first talk. And then the bottom half is in that intro to machine learning part. So typically when you approach a data science problem, the first thing that you have to ask yourself is, what are you researching? So what the research question is. And then you collect the data. And then you spend a lot of time cleaning and exploring. This is actually, I think it's something people overlook a lot because machine learning is such a buzzword right now that it like sounds really, really cool. And it's a lot of fun. But really where most of the time spent as a data scientist is in the data cleaning. That's like where you really need to spend a lot of your time being thorough, because if that is not done well, then like your models have no impact. So it's really important to know what we're going to teach y'all today, which is how to like handle a data set, how to clean it, and how to do some like initial analysis with that before you get into the really heavy modeling. So that's what we're going to go over. All right. So part 1, data wrangling. I don't know if y'all have heard of pandas before, but pandas is a Python package that is used just for this. So it's really to help you be able to manipulate data, to clean it up, and to get your data in a form that you can then run some models on. So the first step, and I'm going to run all these live, is to import pandas, and you can do it with this syntax right here. And I think, let me know if it's too small for y'all and I can zoom in too. Is it good? Y'all can all read it from here? Cool. So that's how you import pandas. And then pandas puts your data in a couple of different structures. The first is a series. So a series is just a 1D array. So it's kind of the basis for what a data frame ends up being. So in this example, you can instantiate a series by doing PD, which is what I imported pandas as. And then pd.series, and you input some kind of iterable. So I put a list in there, and then you can index it. So if I do this, and you can already see what the output's going to be. Index ends up going right here. So that's what your labels are. And then the series values, this iterable, is right here. So this is kind of what a series looks like. You don't work with series too much because most data sets are much more complex than just a one-column data set. But this is like the basis of what a data frame ends up being. So then I don't know why there's extra blocks. So data frame is same concept, but you extend it out, right? There's just more columns, there's more variables. So it's a 2D data set here. And you instantiate it very similarly. So it's pd.dataframe. And then in it, I'm passing a dictionary. So purposely, each of these attributes are a little different from each other. So we have one here, name, which is a list of strings. We have hair color, which is categorical. So you don't have to declare it as categorical if you don't want to. I just do here. It allows you to like do a couple more tricks with it, but it won't mess it up if you don't do this pd.categorical, but that is a way that you can declare it. And so in here, there's all the different hair colors. Weight, so that's numeric, right? Birth date, pd.toDateTime. That's actually really, really useful because a lot of times when you have different types of dates, it doesn't process right because Python doesn't really know what to interpret it as, whether it's like a string or a number. So if you do this in toDateTime, that helps it know that this is a date. So that's really good to use. And then again, state is a string. So if you put all of these in here, it's just a dictionary of what I'm naming it and then what the values are, and run it. Then this is my data frame. And df.head right here, that means it just takes the first 5 rows. So a lot of times you use that to preview it because data frames can just get so big that you don't really need to see all of it. So this is just an overview of what a data frame looks like. Are there any questions so far in like what series or what data frames are? Oh, good. Awesome. Okay. Moving right along. So throughout this section, I'm going to go over lots of different features that you can do on a data frame and like how to just get your data in a good position. So something that you may need to do is drop a column. Whether you just don't want to include it in your models, it's not that important. Maybe you have a ton of null values in that column, and so you just can't predict off of it at all. This is just a way to do it. What you do is you take your data frame, .drop, you put in whatever column you're wanting to drop, and axis equals 1. There is a way to drop rows, so axis equals 0 would drop a row instead of a column, but you mostly just deal with columns in data frames, so that's what I'm showing here. But so in my initial data frame, if you look, we have this column state, and then here, if I drop it, it disappears and it's gone. One thing also to note about pandas is if you were to just say df.drop, it would show you the same output, but it actually doesn't save it to the data frame. So if you want to make the change to the data frame permanent, you have to assign it df equals. I know that's something that really has tripped me up a couple of times because it's not like not every Python package works that way. Some Python packages you can just like run the function and it makes the change. Pandas doesn't. You actually have to assign it again. So that's why we're doing that there. So the next thing, selecting. So there are a couple of different ways that you can select a row or column, sorry. So if you do this right here, df name in brackets, that'll take the name column. Another way, the syntax is the exact same, is you can do df dot whatever the column name is, and that'll get it to you. So these will both do the exact same thing. So if I run it, then I just have that column you're looking for. You can select more than one column. So let me see what my columns are. If I wanted to do name and hair color, I'm going to comment that out real quick. Then I can do both. And then you get both. So you can put in as many as you want there. And so that's another way to get columns you're looking for. You can choose to select things based on different Booleans. So in this instance, what if I only want rows in the data frame where they have a blonde hair color and their weight is over 150? This is a way that you can do that. So you can sub-select based on different attributes. And that's kind of the syntax for it. So it looks really similar, but instead you just have some of these Boolean cases. And then there's also a way to use what we call iloc. So if I want to do this, it's df.iloc, and then you give the index of whatever the row is. So in this first instance, you'd only be getting the first row. In the second, you're actually getting 3 different rows. And in the last, you're doing it over a range. So these are just different things to show you kind of how you can do that. One other thing to notice is that in this, the only code that's executing, which may not be clear, is the last one. These other things aren't showing because I'm not printing them. So the output right here is just this one. But all the syntaxes would work. So it's just showing you options. And you can do rows and columns if you just add in a comma and then whatever column you're looking for. And you can also do it with the label, but here you have to say loc instead of iloc. So in these sections, we've shown you how to kind of drop columns and how to select columns. And here's all the syntax that y'all can use to do that. Any questions so far? Good? Okay, cool. That's important. So now we will talk about how to sort data frames. There is an attribute called sort values, which is really handy. You just put in this by parameter. You can say what you're wanting to sort it by, whether you want it ascending or descending. And so in this instance, we have decided to sort our data frame by birth date. So you can see now it's all rearranged, and the index, you can even tell like what the original indices would have been. So you can see that it's really mixed it up there. It's a good way to look at it. This can help too if you're trying to do more of like queries on your data frame. Even sorting it a certain way and like just outputting the top few can help you answer some of your questions. Like if you had any questions about who's the oldest or who's the youngest in your data frame, by this you can solve that pretty easily just by running a sort values. All right. So if you are curious about different types of information that you can find in your data frame, this section goes through a lot of different attributes that you can use for that. So firstly, if you wanted to figure out what the different data types of your columns are, you can just do .dtypes, and it'll output that for you. This is nice because sometimes when you instantiate a data frame, you don't actually know how it chooses to interpret your columns. And so before you do any kind of modeling, you need to make sure that they're the right data type for your problem. And so here you can see that name is an object, which is string, as we showed. Hair color, because we did that pd.toCategorical, it is a category. Weight is an integer. Birth date is date time, again, because we did the to-date time. So this is a way to just check and make sure that everything is in a good shape before you continue. If you need to figure out the dimensions of your data frame, you can do .shape, and it'll show you the number of rows and the number of columns. If you just want to list your columns, which I use pretty frequently, especially when you get a little bit further into modeling, it's kind of hard to keep track of what the data frame is actually. So I'll type this in before I go to model just to make sure that I know what columns are in my data frame. It's a good way to pop that out for you. And then also, if you just run df.info, you get kind of a lot of the information that I talked about that you can use the other attributes for. You get each of your columns, you get what their data type is, and you can also see like the non-null count. So that's how many, how many entries are not null there. So that's what df.info does. And then if you have numerical columns, so in the data frame that we're using here, you only have weight, which is a numeric. And if you do df.describe, it gives you all the descriptive statistics of those columns. So you can see, count, mean, standard deviation, min. So all of those things you can run here pretty automatically. Any questions so far? Nope. Okay. So null values, this is a big one. This is an area that is so important to make sure that you get right, because it can really impact any type of analysis that you're doing. It's a question that you have to ask yourself is like, how many null values are there and how do I want to handle them in order to make my data frame a little better? So I'm going to actually, so in our original data set, we didn't have any null values. And so in order to show you like how to find them, I am inputting one here. So what I'm doing is, if you remember, a way to select the entry, so you can do the dot look, and I'm going to choose the first row and the hair color column, and I'm going to set that value to a null value. So that's what this is right here. You can also just use this if you want to reset a value in general. You could assign it any value and it would change it there. So I'm going to do that, and then as you see, now this value is null. So we have a null value in our data set. And then in order to see how many null values you have, there are actually a couple of different functions that you can use for this. Pandas has multiple, but one of them is to do df.isInA.sum, so that'll count them for you. And so if you go down here, it does it by column, which is nice. So now we know that hair color only has one null value, and that's the one I just input there. Some other things that you can do is this one. So if you do .any, it actually, instead of giving you a count of how many there are, it just says true or false, like as to if there is a null value in that row, or in that column, sorry. And yeah, so that's a good way to see it. And if you want to drop, so with null values, I showed you guys how to drop columns. So sometimes if a column is mostly null, you're probably not going to want to use it in modeling just because you don't really have the ample data that you would need. So when I showed you df.drop, you could go ahead and drop that column. That's a good time to do that. Other times you may pretty much have all non-null values, but there might be a couple of rows that you don't have complete data for. And so maybe you decide it's easier just to take out those couple of rows because I want that column, but I don't want any messed up data. So a way to just take out some of those rows with null values is to do df.drop in a axis equals 0. That means it's going on the rows, and it'll just drop any row that has a null value for you. So it makes sure that your data set is complete. Other things you can do with null values, and I don't really hit on it here, but sometimes you can try to guess what the answer would be. So for instance, if you had a column that had it was pretty much complete, but you had like one or two, you could maybe figure out a way to guess what that value would have been if it wasn't null based on some trends. So you could try to like replace the values. But that's a little more complicated, so I didn't give you an example for that one. All right. So what if you need to make some changes to your data frame? Well, you can apply functions to it, and this will edit it a little bit. So in this example, we do df.apply, and we're doing a lambda function. And so what we're going to say is that we're going to take the name column, then we're going to add this dash, and then we're going to take the hair color column, and we're going to make a change. So what this will output then is a combination of just that. So it'll go throughout the entire data frame, taking those parameters, making it new, and that's what you see here. So that's what this one will do. You probably wouldn't really need to make this exact change in the data frame. This is just an example to show you how you can use the apply function. But that's the idea. So if you need to do any kind of manipulation, you could. Yes?
What's the meaning of axis equals 1 here?
Axis equals 1? I think it's just because it's taking, it's wanting to make it a column, right? Like it's going column by column. So it's applying, yeah, makes sense. So some other things that you can do, the string operations can be pretty useful. I know I've faced this before, like anytime you have applicant data, for instance, like people type in their names very differently. Like some people will capitalize, some people won't. Same with state. Like state is a really good example of this. Like the number of people who like, yeah, anytime you get user entry, you just never know what to expect. So if you need things to be the same, sometimes during good analysis on it, string operations are really good for that because you make sure that everything is consistent. So you can get, right here we're extracting a column, right, df.name, and then we can do .string because name is a string, right, that column is full of strings. And then we can do .lower, and so that'll make sure, if we ran that one, it would make sure that everything was lowercase. That one, again, it does, you don't see the output here because it's the bottom thing that's running. But you can also do .replace, and so that would replace e's in this case with dashes, and you can see how that goes. So apply can be used to do some more complicated changes to your data frame, but the string functions are really helpful for any time you have string columns too. You can try to make everything consistent and make some changes there. So those are good ways to change your data frame. Okay, so group by. This lets you really alter the whole way the data frame looks if you want to group by some types of classes. So for instance, right here, we're going to say we want to group by hair color, which if you remember, hair color was a categorical column, and we had a couple of different categories. And so it lets you do some summaries if you were to like put all of the people in a box that had blonde hair, brown hair, red hair, etc. So if I do this, I can group by hair color, then I can choose the hair color attribute, and I can count them. So this way I can say, oh, how many people are in each of these categories. You could do some different things here too. Like if I wasn't interested in hair color, maybe I was interested in one of the other variables. Like say we still had state and we wanted to know if there was like some kind of relationship between hair color and state. Maybe you could figure out like how many people were across each. Does that make sense? You can kind of like do some measurements, but you're using that group. So that's how you would use group by. And you can do multi-index here. So this is kind of what I was getting at with my example of hair color and state. But you can show, like in this instance, we want to know both people who have like certain hair colors and names and get the counts of those. So that ends up being this is the output of your data frame. So it'll look a lot different than your original data frame. And you can, I think this is, yeah, and you can, yeah, that's how it looks. So are any questions on group by? I know it's a little more complicated. No. Okay. And combining data. Okay, this is huge too. So if you're going to take away something, knowing how to do this is also really, really important because it's not very often that you only have one data set that you're working with. A lot of times you have to go collect multiple different data sets and then put them together. So knowing how to do what I'm about to teach you is really important. So I am going ahead. We had one data frame already that I made at the very beginning of this lesson. And in order to do combinations, we need to make another one. So here's another data frame that we're making. It has color and a couple of different colors, and then RGB, which are just like the values for those. So the thing that we use to go ahead and merge data frames is called pd.merge. And so I'll go over what this syntax is. So you take your two data frames that we're trying to combine together, so in this instance, df and df2, and you can choose how you want to do this merge. So in this instance, we're saying we want the left on to be hair color. So we want to combine hair color and then color on the second data frame. So that's what left on refers to this first one, which is df, and right on refers to the second one, which is df2. And so what it's going to do here is it's going to match those two columns. So you see now that so if you were to like draw a line here after birth date, that's the first df, right? And then the second half is the second one. So what it's doing is it's going through and it's saying, oh, there's red here. Well, we're going to merge it with the second data frame. So whenever it has red on the second, we're going to input the rest of those values and just attach it to the end of that row. And then so it goes all the way down. So that's kind of why you notice there's like repeats here. So these two are really like these 5 are all the same values, right? Brown all the way over and down. It's just because it's merging on whatever this hair color is. And there are lots of different ways that you can do this merge too. You can do like inner merges, left merges, right merges, outer merges. There's lots of different ways that you can combine data frames and you can choose. So in some instances, like we might want to drop one of these columns too. You might not want hair color and color in there because they're the exact same values in the row. So you can choose to go ahead and like drop and simplify your data frame there too. But this is how you would do that, and it's super important to know how to do that because it happens a lot. So, any questions on that?
What if the column numbers are different? Like row numbers are different when you join.
Remember, our original DF is this long, so it's 9 columns long, or 9 rows long, sorry. And the other one is only 4. So this is our original DF2, right? But since it's merging them together, that's why it's inputting the same thing on the right. So it's going to give repeats of DF2, this particular merge. It's just like attaching whatever the value would be to the end of DF1. Does that make sense? Yeah. So it's going that way. So you'll see lots of repeats here, but that's just because it's merging on them. All right. And lastly, input output. So far, the data frames that I've been making, I've just been creating by myself, right, with pd.dataframe. That's really probably not realistic for what y'all are going to end up doing. You're not going to like custom create your own data frames very often from a dictionary that you make. What you're going to be doing is pulling in data from other sources and then needing to convert those files into data frames. And luckily, Pandas does that really, really well. So they have some functions here, like this one, pd.readcsv. If you were to use that, and you can put in any file here, then it automatically will go ahead and it'll take that into a data frame format. And when it does this, that's when some of these other things that we've mentioned become really important, like needing to realize what data types it interprets it as, because you're not setting it yourself when it reads it from a file. So you have to kind of go in and make those checks just to make sure that it is like parsing it the way you want it to. So you can do that. And then they also have other ones. They have like read JSON. I think they have read Excel even. There's lots of different options depending on what your file is in. And then if you want to save it back to a CSV or to a JSON or something else, you can actually do that. So if you make a lot of changes in a data frame and you want to save it as a file, you can do that by doing to CSV or like to JSON or whatnot. It's the same format and it'll just save in your local system. And just to show you like how you can do this on Google Colab too, there is code that you can run. I don't have it on here to like connect to mount it to the drive. I find it easier to use the UI. I think it works pretty well. So over here, like this is your file system, and it makes like a local area for you on Google Drive or on Google Colab. So you could hit this and you can upload files from your local file system. You can also mount it to Drive, and if you do this, it'll connect it to where all your Google Drive files are, and then it shows up in here as a file system. So then you can like pull anything that's on Google Drive, which is really nice. So you don't have to really download anything from your computer. You could just like download it to Drive and then run this through there. And then if you do that, like if I had a myfile.csv here, it would just pull straight from there. So that's how you do input output. And if y'all get started on the challenges today, that's a good way to do it too, is just to keep it in Drive and then pull it from there. So that's how you do input output. All right, okay, so we're gonna move on to data visualization. If there aren't any more questions about pandas, do y'all have any? So the two packages that we're going to go over here are Matplotlib and Seaborn. So Matplotlib is it's a pretty basic data visualization library. It's integrated with NumPy and with Pandas, so it's actually kind of built into some of your Pandas functions, which is nice. And Seaborn is like a wrapper around Matplotlib, so it's fancier. It allows you to do some extra plotting that you couldn't do with Matplot. And yeah, it just produces generally prettier plots than Matplotlib does. And it also integrates, but we're going to show some examples of both of them and to import them. So Pandas we already talked about. Seaborn, typically I see people import it as SNS. I'm not actually sure why, but that's like the standard that I see a lot. And then Matplot is import matplotlib.pyplot as PLT. So that's how you would import those. All right, so this data frame is actually the same one that we've seen before. It's just here again for you. and we're going to add some extra information just so we can do some more with plotting. So I made a series called heights, which is a dictionary, so each name has a height associated with it. And then we're going to do a join, which is similar to a merge, and put them all together. And when we do that, you can see this is our new data frame. One thing that I did here that I didn't talk about in the Panda section is this set index. So the default index is just numerical. It's like 0 counting number of rows, basically. But you can set your index to be a column value. So in this case, I'm now making the index my name instead of an integer. So that's what I'm doing here. That's why it looks a little bit different. Yeah, and joining is, like I said, it's similar to a merge. There's not as much functionality that you can do with it. So actually exactly what you can do in join, you can do with merge too. But it's more used if you're like just appending onto your existing data frame. That's kind of when you would use a join. So you can always just use merge too. And so that's what we end up with here is this data frame with that extra height column. And so now that we have this, we can show you how to do some plots. So the first one we're going to go over, actually the first couple of these are for numeric variables. So they're how to plot those kind of variables. So scatter plots first, they are used to see the relationship between two continuous variables. So you can do this by doing sns.scatterplot. You can choose what your x and your y are. So here I do x is weight, y is height, and then you have to say where the data frame is that you're pulling it from. So this is a syntax for how to use it. And then you do plt.show. So if you notice, SNS is seaborn, right? So we're making a seaborn graph, but it's integrated with Matplotlib. So actually to like show the graph, you can do plt.show. So that's how you end up doing it. And then it produces a graph like this. So that's what a scatter plot would look like. And later on, I'll go on and show you how to customize like your axis titles and all that. But right now, this is just how to make a scatter plot. So another thing that you can do is if you want to do a scatter plot, but you want to group it by a categorical variable, this is how you would do it here. So it starts out the same, right? It's still sns.scatterplot, and you input your x and your y. But you can set this hue equals to a value. And so here I'm choosing hair color. So now I'm making my scatter plot, but I'm going to color it by whatever the hair color is. And so that shows here. So that's how you do that one. If you want to add a regression line, this can give you a good preview to what maybe a model would do for you. You can see like where that line would fall. It's sns.regplot, and the syntax in terms of what's in the parentheses is the exact same as what you've seen before. So that's a way to kind of get a good prediction as to if you were to fit a line, what it would look like and what your confidence intervals are through your data set. And right now, again, this data set is really small. So if it was much bigger, you might see some more there, and definitely you'd see like a smaller confidence interval with more data. Yeah, that's what the shaded stuff on the outside is your confidence interval there. So yeah, the line is like whatever the regression line would be, and then the confidence intervals are on the side. So you can see there. And then here's a way to do it if you want to group it by categorical here and add regression lines. So similarly, the only thing that you have to do here to change it is to do hue equals hair color, and that's going to create that grouping for you. And then I added this right here, ci equals false. I am turning off the confidence interval for this plot. And the reason is if you add it right now, it's huge. The confidence interval for this is just giant because there's only like 4 data points in each category. And so if I were to turn that on, the whole thing would be a confidence interval. So that's why it's off, but you can add it back on if you were to get rid of that. Yes, this one is different. This one's reg plot, and then this one's LM plot. It's a little bit different. But yeah, these are all really great ways to do it. So kind of if we think about that like data science process that I showed really early on in this lesson, the first thing, right, is to ask your question. The second thing is to collect the data. And then what we started learning here is first that like the Panda stuff, which is cleaning it, and then next exploratory analysis. So before you start any modeling, like these are the kind of things that you produce just to get an idea of what's in your data frame and what the relationships between everything are and what you're seeing. So knowing how to do all this is really cool. And depending on your data set and what kind of data you have, any of these plots can like really help you take that next step in figuring out what you're going to do. Like how are you going to solve it just based on what you're seeing. So these are really great things, and the seaborn plots are really pretty, so that's nice. All right, so line plots. Line plots are used to track changes in y over a progression x. So to do this, it's sns.lineplot, and again, you just put your x, your y, and your data frame, and then you can see the trend. So it's just a line plot here. And then I'm going to make another data frame. So I think this is actually, you haven't seen this data frame before. It's a little bit new, but it has the columns. It has birth date, and then house price in thousands, and net worth in thousands. So this is what this data frame is. We're going to use it to do some modeling. So if you want to do multiple, so this is the reason that we had to add a different data frame here is in our original data frame, we only had one, I think we only had one numeric column. And now I just wanted to show you that you could do it with more than that. So in the new data frame, we have multiple numeric columns. And so what we're doing here is we're plotting multiple continuous variables against a single continuous variable. And in order to do this is actually, your data frame has to be perfect to make this graph work, so you may not use it that often. But for this one to work, your x-axis has to be the index. So here my index is birth date, right? I set it as birth date. And then the columns are continuous, so both of them are. But if you do this and you just do sns.lineplot with your data frame, it automatically will pull the index as your x-axis and the other columns as y's. So this is cool if you ever in the situation where you can get a data frame to look like this. It plots this without much work. It's really simple. You just pass in your data frame. But that's a cool one. All right, so styling. So this is where we actually get to go and customize the graphs a little bit more. So there's a lot in here that we're adding. So I'll go over it one by one. So to do this, if you do plt.figure and fig size, that controls like the size of the figure that's being outputted. So if you notice, this figure down here is much bigger than all the other ones that we've made so far, and that's because we adjusted that. So you can change the size of your plots with that. plt.title. So this will add a title to your graph. You can also customize the size and the style of your title. Then I go here, and so again, the styling is done with Matplot, right? If you notice, it's PLT, it's not SNS. So you add all these additional configurations through Matplot. So that's how you do that. And then I'm going ahead and I'm just making a line plot. We already showed you how to do that. Legend. So the legend area will control this right here. So here I'm saying that I want these two columns to be shown. So that's how you see that. Y label, I'm adding as dollars. It adds this area right here. X ticks. So you can add these markers if you do the X ticks, and you can say what rotation it is too. So right now it's 90, so it's going to show like exactly perpendicular to the x-axis, but you can make it different to you. So maybe if you had like really, in this instance it would work because it's only the length of each name is 4 because it's a date. But a lot of times you would keep it at 90 if like if your ticks are really long because they just like overlap. But you can make it, you can just adjust like the direction of your labels. And then I'm showing it, so that's how the graph ends up going. And there are other ways that you can customize it too, like there's also, for instance, there's like X label and Y ticks and all those parameters too. So it's really customizable, which is great. All these plots are. All right, bar charts. So the first couple things I showed you were for what to do with continuous data, so numerical data. And now we're going to talk about how to plot categorical variables. So this first one is a bar chart. You use it when you want to represent the frequency of each of those categorical variables. So what I'm doing here is I am editing my data frame so I can end up showing you guys this a little better. But I'm grouping by hair color, and then I'm taking the mean weight for each hair color. And then I'm going to make a bar plot. So what I'm choosing to do here is I'm just doing index and values. And then you can edit the palette of seaborn things, so you can change all the color schemes, which is really cool. And there are a bajillion different color schemes that you can put it into. You can just Google them online. There's like a reference list of a ton that you can change. So this is the plot that ends up coming here. It's just a bar plot. So that one would look like pie charts. So pie charts are used to see a percentage breakdown across a categorical variable. I'm going to try to run this, but I may have to go. Oh, okay, it worked. Cool. So the thing to note about this, though, is that you actually do pie charts not with Seaborn, but you do them with Matplotlib. So this is the first thing we've seen so far that we haven't made with Seaborn, and that is pie charts. But to do this, you just input, again, your X and your labels, and then you can like change what goes in the slices too. So that's kind of what this is doing. It's adding the % there for us in the formatting and showing it. So that's how you make a pie chart. Heat maps. Okay, I think these end up looking super cool. I'm going to try to run it for you. Okay. So a heat map is used when you want to show a continuous variable grouped by 2 categorical variables. So that'll make a little bit more sense when we show you what these are. But to do this, we have a new data frame, and this data frame is about taxi rides. So we have the attributes month, weekday, and distance. And this is what our data frame ends up looking like after we do some manipulation with it. So you have month and weekday, and then the values are the distance. So you notice there are a lot of null values here, right, in this data set. That's what all the NaNs are. And then to do a heat map, you just do the seaborn.heatmap, you put in your data frame, and this is what it ends up looking like. So I'm going to blow this up a little bit so you can see it. But I think these end up looking pretty cool. They're really good to help you identify clusters in your data set, so you can see like certain areas that may have a high frequency and like where the interactions between your variables is high. And so here I'm pretty sure this is just the count that's showing right now, but you can see like the number of rides that happen in like the day and the month here. So that's what it looks like. You can see like when, so in this instance, there are a lot of rides that happen in like this area, right? So that's what heat maps are used for, which can be helpful. Okay, and then box plots. So these are used to visualize the distribution of your quantitative variables. So in this instance, I'm making hair color and weight, and then I changed the palette again. And you can see it's just, if you're familiar with stats, this is like your interquartile range, right? Your min, your max, your median, all that kind of stuff. So this is how you make that here through Seaborn. Okay, this one right here, yeah, this one is super cool. I highly recommend using this next one that I'm going to show you when you start to do any of EDA, because it's like you get a lot for the one line of code you write. So with this, we are going to add, I'm going to go ahead and add another continuous variable to our data frame. So I'm adding number of kids, and then I'm just going to join it. So I just made another variable here. That's what this is showing. To do this is called a pair plot. So this is what the output ends up being, which is really cool. It basically takes all of your continuous variables, and it automatically plots each of them against each other. So like this first plot is, I need to zoom out so I can read the labels. So on the diagonals, this is when the like X and Y axis are the same, right? So it would be like weight versus weight. And so there it does a distribution for you. So this is a distribution plot across the categories. So that's what you're seeing all along the middle. And then on the others, those are scatter plots of the 2 continuous variables against each other. So it automatically plots distribution plots and scatter plots. So this is just like a cool graph because it kind of does a lot in one. So it's a good one to do when you're just starting out. So you can see a lot for the one line. And then something else to show. So if you want to plot, like do it a little more customized, this one gives you a lot of plots with one line of code, right? But if you want to add multiple plots and kind of make an image yourself, you can do that with this subplot feature. So you end up just basically assigning a quadrant or whatnot to each plot that you're making. That way they plot all together instead of individually. So here I'm saying that I want a 2x2. And then what I'm doing first is plt.plot. We didn't really, this is just a line plot using, so when we did it, our line plot, we did it with Seaborn, so it was SNS.lineplot. You can do it with Matplot too, it's just plt.plot, it's the same one. And this is what I'm plotting, so this is this first one you're seeing right here. And just to, yeah, I think I need to be a little more clear with this. So in this subplot right here, so we know it's a 2x2, and we're taking the first one, the first box, which is why it's here. That's what that one means. So here we're doing it's a 2x2, and we're taking now the second one, and in that second one we're going to make a pie graph, so that's what's here. And then again, this next one will be a bar plot because we're doing 2, 2, 3, and then bar plot. And then lastly, in this fourth one, we put a scatter plot, and then we show it. So the reason that you would want to do this is if you just wanted them all together, instead of like running them on different lines of code, you can make your own image. And when you like save this image, it would get all 4 of them instead of having to like go get one at a time. So it just kind of lets you customize it a little bit better there. And then last one. All right. So this helps you like kind of almost recursively make the same plot on different types of data sets. So this is called a Facet Period, and it's through Seaborn. So what I did here is I just loaded in a data set from that's like pre-made and in Seaborn. And then you can do this facet grid. So here I'm using the column survived and the row. This is just the class of the passenger. And so what it does is it takes every combination of that class and it produces the same plot for it. So it helps you like recursively see it through your data set. So in this instance, we're making a histogram, right? That's what this hist plot is. And you can see it for when the class is 1 and survived is false, class is 1, survived is true, all the way through all the different classes. So it just lets you like, yeah, it helps you do multiple things all at once. So that's this one. So I actually made it through with time to spare. I know that was a lot of material. So the things I showed, this is definitely like a crash course data science. And I was hoping that the layout of this collab will be really helpful for y'all to take and go apply to projects, because you can kind of go back and just click on anything you're looking for. And the code is right there, and it should be very like, you should be able to like use that for whatever you're wanting to do. So if we just start again with like the process, right? So here is where you start using pandas. You want to clean your data frame. You want to make sure that you have all the rows with all the types, that you take a look at your null values, and you make sure your data frame is as complete as it can be. And so you have to do some of those manipulations to get it there. And then from that, once you have your data frame in a place that you're confident in it with, then you start doing some of the EDA, some of the plotting, looking at some of the distributions of each of the columns just to get an idea of what is in your data frame. That way you can decide what may be important to go on and then model. So that's kind of what we chose to show. And then the packages that you use for that second section, again, they're like Seaborn and Matplotlib, or we showed. There are others, but that's what we showed y'all today. So are there any questions? Do y'all have anything you want me to answer? If not, that's great. But I'm just like, yeah, thank you guys so much for coming and for listening. And if y'all have questions at all, like throughout today, just as you're working on stuff. Oh, you have a question? Okay. It runs off of Google Cloud. Yeah, it doesn't. That's a benefit to Colab over Jupyter Notebook. Is Jupyter Notebook runs on your own server, right? So this works with cloud, and there's a lot that's free. You can like pay to add more if you need more, if you're like doing a really high project, but that doesn't happen too often. It does pretty well. So it's nice that it doesn't run on your resources, which is really good. It's also shareable, so it actually like I can show you. So within Drive, it'll like make a folder for you automatically called Colab Notebooks, so you can actually access all of this like through Google Drive like you normally would too, which is really nice. It's just integrated with all your stuff, so that's what Colab does. It's cool. They have a lot of really good features. I recommend it. But yeah, I think I was just saying, if y'all are working on projects throughout the day and y'all need help with like pandas or Matplot or Seaborn or whatnot, come find me or anyone else, and we would like be happy to walk y'all through how to do it. But
can we give Allie a round of applause?
So yeah, thank y'all for coming. And then we'll start the other class at 2, and that's like